table show, we're on page 198. So unfortunately, the different classes got the different points, so we're just kind of picking up here for the recording. On this one, the table shows the number of muffins in a specific pack. Complete, guess the missing cells in the columns for the 6-pack and 36-pack. In other words, right now, we've given you what was in the 18-pack. I want you to do the 6 and the 36. Yes? 199. Okay. Yeah, sorry, Mr. Candace labeled this one. So it's on page 199. We need you guys to finish off the 6 and the 36. And then I want you to answer 7, A, B, and C. We'll give you guys about 4 minutes to do that.
All right, so the only information they gave us was for an 18-pack of muffins, yes? So that is where we are starting. Can I do something to go from an 18-pack to a 6-pack evenly? What? I can divide by 3. So I'm going to take all the numbers that are 18 and do the same thing to make equivalent ratios. So what is 9 divided by 3? 3. What is 6 divided by 3? 2. What is 3 divided by 3? Now I have equivalent ratios since I did the same thing to every number in the column. Does that make sense? Stop talking while I'm talking, please. Now, using the information at the beginning of my table, can I do something to 6 to get to all of the other numbers in my table? All right, what would I do to 6 to get to 12? By 2. So 3 times 2 is? 2 times 2 is? 4. And 1 times 2 is? 2. All right, can I do something to 6 to get to 24 evenly? What? Times 4. So 3 times 4? 2 times 4? 1 times 4? Notice, I am still going back to the numbers that are under 6 because that's where I started. Make sense? What would I do to 6 to get to 36? By 6. So 3 times 6 is? 2 times 6? 12. And 1 times 6? 6. Any questions? Encourage him to be more dramatic. All right, number 7, analyze the columns. What do you notice about the numbers? It's making equivalent. Okay, but it is actually making equivalent. What are we talking about right now? Ready, she knows. I'll wait. I don't talk over well, but nobody on the video was hearing. I'm waiting because people are still talking while I'm talking. What else do I notice about the numbers in the columns? Look at each row from left to right. So, all of the bottom is in red. The model, it's less than, but it goes 1, 2, 3, 4. So the total number of muffins on the top is 6, 12, 18, 24, 26. They're all multiples of. They're all multiples of 6, 2. And then 6. And then the second row, they're all multiples of. And in the third row, they're all multiples of. And in the fourth row, they're all multiples of 1. So we are making equivalent ratios. Each row has a pattern. Row 1 are multiples of 6's. 2. Row 2 are multiples of what?
3. Row 3 are multiples of? Nope. 2. And row 4 are multiples of?
1.
There we go. Oh, all right. B. How could you have determined the number of each muffin in the 18 pack without using the tape diagram that we used on the page before? What could we have done? What did we just do in our table? So what did we just do? I said it about 8 times since I stood up here. What kind? We could have maybe put on the ratio. How could you have determined the number of each type of muffin in the 36 pack without using a tape diagram? Equivalent ratios. Use what you notice about the numbers in the table to determine how many of each type of muffin are in a 12 pack and a 24 pack. We have already done that. Yes?
Yeah.
Okay, let's look at the next page. We just used tape diagrams to represent and solve ratio problems. What other strategies can we use? Well, we already used tape diagrams, so we're going to find other ways. And I am still talking over people, and I do not like it. Coach Robert wants to encourage her swim team to increase their speed. She will give an award to the team member of the swim team who can swim the most laps in 20 minutes after the practice this week. The table records the results from this week's practice. Everybody see the table? Good. Using the information in the table, I want you to explain how Tia's reasoning and Lisa's reasoning about who will win the award are incorrect. How do I know they're incorrect? Just by looking at them without reading anything. They both have a thumbs down, so I know they're both wrong. Yes? So as a table and using the chart at the top, discuss why they are wrong. What did each of them do incorrectly? Give you about 4 minutes and then we'll come back. Go for it. You can tell me what Tia did wrong. She says Susan will definitely win the award because she swam the most laps. What did she do wrong?
What she did wrong was she did not try to multiply like two to make it 20 minutes in total, and she would have gotten 14 laps, which is not the most in all. She was assuming because of the 4 laps to time ratio that she would get.
But she only looked at which part of it?
The laps, not.
She didn't look at her time at all. She only looked at the laps and said, okay, she won, right? So Tia did not look at the time it took. All right, Lisa says it took Susan the longest time to swim her lap. She will not win the award. What did she do wrong? She looked at the time. She didn't look at the lap. So looking at this, who would win the award?
Okay.
K would win. Because if we make all of those equivalent ratios, what would our least common multiple be? 20. What would I multiply 5 by to get to 20? So 4 times 4 would be?
16.
What would I multiply 10 by to get to 20?
2.
So 7 times 2?
14.
What would I multiply 2 by to get to 20?
10.
So 1 times 10?
10.
And 4 to 20?
5. 5.
5. So 3 times 5?
15.
So that is how much each ran in 20 minutes, and K swam the most laps. Make sense? Good job.
Highlighter, marching pen, we have the definition. Okay, our first one is each quantity in the table is what we call a rate. A rate is a spectral ratio that compares two quantities measured in different units. The whole key in a rate is I've got different units. In other words, the most important thing about most important part of a rate is writing down the units. Because that's what tells me I've got a rate. It's comparing two different units. Okay? In this situation, it was number of laps and the amount of time. This one we skip. This 203.
That is still one.
So one. Okay, so exactly one we skip. So in this case, we can take the ratio that they've given us and we can write it as a rate by turning it into a fraction. So if I take my rate of 4 laps in 5 minutes, we can write it in fractional form. Again, the most important part in a rate is our units. That's what we're comparing. So we're giving you an example. Now we want you to write the rates for the other 3 team members. And then we've got a couple questions for you to answer. Actually, this one's not. That's it for this one. We can take you all about a minute. Go.
Fine.
Actually, part of this is, as soon as I finish it, I'm looking over on my side now, the person's already done, and I go and look, and all they have is numbers. What did I just say is the most important part of unit rate? The units. Then I have one on this side who's like, wait, do I have to write down the unit? I wasn't given out the names for a reason.
Yeah.
Guys, the most important part in a unit rate is the unit. Yes, you must write the units down. And it's not that hard. So what was Susan's rate?
For about 10 minutes.
What about for done? What about for or do I need to read guys? No. Do I need to write down the words? Absolutely. That's what a rate is. If you have not written down the words, you don't have a rate. The difference between a ratio and a rate is the words. So if they're asking you for a rate, if you don't have words, you're wrong. Okay, here's another definition for us. And this is something we've been doing. We just didn't give you the word for it. And that is a proportion. The key out of proportion is it's an equation that states the two ratios are equal. The most important part of a ratio is that equal sign right there, guys. As soon as you see that equal sign, I now know that they are proportional. That what happens on one side, to get to the other side, on the top, I have to do on the bottom, or vice versa. Okay? The quantities composing each part of the ratio have the same multiplicative relationship between them. There's your key. Because that equal sign is there, I know whenever I do the one side, I have to do the other. So in this case, we knew the cadence went 4 laps in 5 minutes, yeah? Which allows us to predict how many laps you will do in 20 minutes. I start with what I know, 4 laps in 5 minutes. I know I want to go to 20 minutes. Here's another key, guys. If you've written down your units, it helps you place the last number. Because if I know it's 20 minutes, am I going to put it here with my laps? No. But if I've got my numbers written down, I know the 20 is going to go there, because that's where minutes is. Now it's just the mathematical reasoning. How do I go from 5 to 20? Times 4. So that equal sign is key because that tells me this is proportional. In other words, whenever I do to the bottom, I also have to do to the top. So 4 times 4 gives me 16. So kids could probably swim 16 laps in 20 minutes. I know that because it's proportional. Does that make sense for everyone? And you aren't confused about what we just did. So 2 key concepts here. Number 1, the concept of proportion. That equal sign tells me I can do things between those numbers. Second is that multiplicative relationship, understanding. Whatever I do on one side to get to the other, I have to do on the other side as well. There's a couple additional terms we're going to throw in here for you that work along with this proportional idea. Your first one is called scaling up. If I change one ratio to an equivalent ratio with larger numbers, that means I am scaling up the ratio. Scaling up means that I'm multiplying both parts by the same factor greater than 1. Everybody good on that? Okay. Scaling up, if it's scaling up, it's just telling I'm multiplying. It's honestly the bottom line. One big key when we're doing proportional relationships, the only 2 operations you're doing are multiplying and dividing. We're not going to be adding and subtracting on any of this. Okay, here's where we're going to skip a page. Let's go to page 203. Most of you this machine decided you wanted to skip a page. Wasn't important. So we're going to practice on scaling up. We want you to scale up each ratio to determine the unknown quantity. You got 4 problems to do that, and then you're going to do 2 word problems that are also scaling up. So we've got 6 problems to do. We're going to get about 7 minutes. So the first ones are not hard. The whole key on these guys. Start with where I've got 2 numbers. Tell me where I'm starting from. Then you got to figure out what one changed. In this case, I went from 3 to 27. Then you figure out how did it change. Again, you can only use multiplication and division. You are not adding and subtracting changes. Because this equal sign is here, that tells you it's a proportion, meaning I'm allowed to multiply between them to get the answer. So how do I go from 3 to 27? Okay. Times 9. Meaning I'm going to take the 1 times 9 and I get 9 yards. Our next one, I start at 2 and 4. I go 2 to 30. How do I do that? Multiply by 15. So I'm going to take the 4 times 15 and I get 60 cups. Here, now I'm doing the bottom one. How do I go from 3 to 9? Times 3. So I take 36 times 3 and I get 108. Here I'm going 20 to 80. How do I go from 20 to 80? Times 4. So I take my 5 times 4 and I get
20.
Are you starting to see the pattern? Okay? It doesn't change when we go to a word problem. Jenna buys 2 pizzas for every 6 people she invites to the party. How many pizzas will she need to buy if she's invited 18 people? The whole key on this, if you will set your initial rate up, it's super easy. I always say you should all, anytime you're doing a proportion problem, start with this. As soon as I know I've got a proportion, I start with this. Now I'm just filling in the blanks. They have to give me at least 3 of them or I can't solve the problem. In this case, they gave me 2 pizzas,
6 people.
6 people.
8 people.
Once I've got those initial units, I just write them on this side in the same place. Pizza and people. And now it makes it easy to tell where that last number goes. Because my last number is what?
18
18
people.
people. So is people going to go for pizza?
No.
No. It will go with the people. If you've written them down, it makes it really, really easy. Okay? Now I go 6, 18. How do I do that?
Times 3.
Times 3. So what am I going to do?
Times 3.
Times 3. What kind of problem is this?
No.
So is this my final answer?
No.
What do I need to do? For an answer. You need to buy. Last one. Stefan runs 5 laps in 6 minutes. How many laps? In 3 minutes. Great. So I've got 5 laps. 6 minutes equals laps. Minutes. What's my third piece of definition?
30.
30 minutes. Like going on top or bottom?
Bottom.
Bottom. That's where my minutes are. Again, if you'll label them, you shouldn't make any mistakes because it literally puts it right where it needs to go. How do I go from 6 to 30? Times 5. 5 times 5 and I get 25 laps. The word problem? So Stefan will run 25 laps in 30 minutes. Questions on anything we've covered so far? Okay, because we're about to get into another concept after we finish this one. So this one is highly related. Last time we were doing scaling up. Scaling down means you divide both parts of the ratio by the same factor greater than 1, or multiply both parts of the ratio by the same factor less than 1. And remember, if I do a division, it's actually the same as multiplying by the reciprocal. We did that when we were dividing fractions, remember? Okay? So they've given us 4 additional problems and 2 more word problems. So we'll give you an additional 5 minutes to finish the slide. Go ahead and go.
Okay, we are going from 6 hoagies for 18 people to 2 hoagies. What am I doing? 5? 3. So 18 divided by 3? 6 people. Make sure you label it. Got it? 100 track shirts for 25 people. What about if I have 5 people? What am I doing? Dividing by? So 100 divided by 5? 20 track shirts. All right, 3 tickets is $26.25. How about 1 ticket? What am I going to do? Divide by 3. So what is $26.25 divided by 3? I only heard a couple people answer that one, so let's do it together. Can 3 go into 2? 26?
Yes.
How many times? Bring up my decimal, down my 2 into 22. That's 21, leaves 1, bring down my 5 into 15. So it is $8.75. And 12 hours for 720 miles, but I want to know how much for 4 hours. What am I going to do? By 3, so 720 divided by 3? 40. 240 miles. Any questions about those 4 scaling down. Good. This time you had to set up the proportion yourself. They did not set it up for you. Mark bought 12 pounds of bananas for $15. How much does 4 pounds of bananas cost? So I have 12 pounds for $15. And I know I'm going to pounds and dollars again. So which one did they give us in our problem? Pounds or dollars? Pounds. Pounds. So it is 4. What do I do to get from 12 pounds to 4 pounds? Divide by 3. So 15 divided by 3? So it is $5 for 4 pounds. This is a word problem indeed. $5 for 4 pounds. And B, Jill can type 750 words in 6 minutes. If she types at the same rate, how long does it take her to type 250 words? So I know I have 750 words in 6 minutes. Just rewriting it as a fraction, and I know I'm still talking about words in minutes. What else do we know from our problem? 250 words. So what do I do to 750 to get to 250? Divide by 3. So 6 minutes divided by 3. It will take her 2 minutes. Next page.
Five. Why this lesson ended up taking us 2 different days. We've actually gone into 4 different concepts in just this one lesson. Okay? So the 4th concept we're going to introduce in this lesson is the concept of a double number line. A double number line is an additional model that you can use. This model is made up of 2 number lines used together to represent the ratio between 2 quantities. Here is the biggest key on a double number line. In a double number line, your intervals on each of the number lines is different, but within that number line, the intervals are always the same. What do I mean by that? Let's take a look at the example, a couple of pieces here. The interval is the amount of space between 2 tick marks on a number line, but the scale for each number line is different in a double number line. So my scale is different, even though the interval is the same. Because the interval is the same, that's keeping that ratio constant all the way across it. But my interval is based on which number line it's associated with. So in our first example here, I've got a ratio of 12 ounces of blue paint and 9 yellow paint on my double number line. I can see other intervals that are equivalent ratios by labeling each of my intervals. So 12 and 9 is where we started, but that is not its simplest form, is it? If I look at my 4 key numbers, what can I divide 12 and 9 by? I divide them both by 3, not 4. I can't divide 9 by 4. And 4 is not a key number for the record. So that tells me I could actually divide this by 3, meaning there's actually 3 intervals before I get to my 9 and 12. So I divide 9 by 3, I know that the first interval is at 3 on the bottom. If I divide 12 by 3, I get 4 for my interval on the top. Once my interval on each of the number lines is set, that interval won't change on that number line. Okay? So here's where this can get confusing. Because what is my top number line going up by? 4. What's my bottom number line going up by? 3. They're going up by different intervals. Meaning my next interval, this next one that's not labeled, would be what? 8 on top, and on the bottom would be 6. It's going up by 4 on the top, 3 on the bottom. Meaning my interval after the 12 would be what? Going up by 4 and 12. Makes sense. Now, here is your key. Here's why the double number line is effective. It means that any of these other ratios that you have in here are equivalent to 12 to 9. So 12 to 9 is the same as 20 to 15, the same as 8 to 6, the same as 16 to 12. They're all equivalent ratios. Okay? And if we have our double number line set up properly, then it's going to give us all of the correct ratios at any given point. So if I were to describe the interval represented on each number line, the top we said goes up by 4. The bottom goes up by 3. So even though my intervals are different, they will be consistent within that number line. So how can those see to create the exact shade of green she needs if she uses fewer ounces blue paint? How does that affect the amount of yellow? That's really the big question on that. If I'm using less blue paint, what's going to happen to the yellow paint? In other words, when I started at 12 and I go down to 4, what's going to happen to my yellow? It's also going to go down, right? Well, the yellow will also go down. If the blue goes down, the yellow goes down, yes. Okay? How can she create the exact shade of green she needs if she uses more blue? How does that affect the amount of yellow? Again, so really that second part of our question. If I'm using more blue paint, what happens with yellow? The yellow will also go up. The key is they're going to go up by a proportional amount. Okay, our next page. Oops, I've got to erase this one. So, in this one, don't see that 12 ounces of yellow. You needed to determine the amount of blue. Oliver and Sal thought about it differently. Oliver looked at it and he said, on the double number line, I use intervals to determine the number of ounces of blue paint I need. He said, I just multiply them each by 4. So the ratio stays the same because we multiply them both by the same number. So that's your answer for why Oliver's thinking was correct. For Sal, Sal was incorrect. Because Sal did not add the same, multiply the same number. What did Sal do? He added the same number. That doesn't work for a double number line. Because my intervals were different. What was my interval on top? 4. She added 3. So she changed the interval completely. So for Sal, she added the same number to both, but the top interval was 4, not 3. So she should have been adding 4 on that top line, not 3. Okay, let's go ahead and go to the homework, page 209. No, it does not. Because this is a really special one, especially on my side where we look at these journals so in depth. That's where we're using a couple of academic terms here. Compare and contrast. Those are English terms normally, but what do they mean? Okay? Likes and differences. Between what? Okay, diagrams and double number line models representing racial relationships. Use an example in your description. Am I going to do a compare and a contrast and an example in this amount of space? No. So this is actually really key today, guys. You're going to need a separate piece of paper for your journal entry. There is not enough room here for you to do it. That's what I'll actually do next Wednesday. Okay. Putting together a bag, prepare for every 2 apples, draw a model, and explain your reasoning. I will give you a hint. Double tape diagrams to me work best on this. So I personally would use a tape diagram, but as long as you've got some form of model, it will count. Pay attention to your app, what they're giving you. They gave me a total of 9. I have to use that to figure out how many apples there are. How many pieces of fruit are there as far as 8 apples? I want a total for part B. Number 3, they've given us number 2, they've given us a ratio for hip hop, 3 country, 1 slow song. Use a tape diagram. Give us an option on this. No. So here's why I feel bad. We would actually have one tape diagram example. So make sure that you understand the tape diagram and what you need for your ratio constant. 40 songs total. So I need to figure out how many total songs there are. Then I can break it down for the hip hop, country, and slow. The next one, they want to put 36 hip hop. So that tells me which line I need to use of my tape diagram to figure out my ratio constant. And then I need to, the answer is going to be how many total songs. Backside, we've given you a scale up or scale down. So basically just look at the number that's changing, figure out what that relationship is. The last one, they build structures in stone. He uses mortar to hold bricks together. General rule of thumb, 2.5 bags of mortar are needed for every 100 cement blocks. They gave us the double number line to set it up. Make sure you're using the double number line to figure out where you need to be. So I need to get 350 blocks, 50 blocks, and then 12.5 bags of mortar. Okay? Once you break, so you'll need to add those 3 intervals onto your double number line. I'll give you a hint. They did give spaces for them to all occur. Any questions on your homework? That's accurate.